Okay, thank you for bearing with me as I went through some of those theoretical explanations in the last couple of videos. I really wanted to give you guys a solid understanding of what is happening with confidence intervals. But in this video, you're going to see exactly how you're going to apply it in this class. So we're going to go back to the IQ example, and I'm going to show you how to find the 95% confidence interval for the population mean IQ of college students, given the information that we were given using your calculator. And so to begin with, the very first thing that we're going to do is we're going to go into the stat menu, and then from the stat menu we're going to go over to tests. And then once you're inside tests, we're going to see a whole bunch of different tests, and if you scroll down you're going to start seeing some confidence intervals. You see it says Z interval, T interval, there's a whole bunch of different ones. And the one that we want to go to is, we actually want to go to number 7, which is called Z interval. And so at this point, this is how we are going to do it, and I'm going to give you a little bit more structure later on because there's a lot of different types of confidence interval tools that we might be using. So most of our calculators should look exactly like this, and the nice thing is sometimes you might be given data in some problems and you could highlight this data piece, but we've been given the summary stats in our problem, so we can change that to stats. And then you can see that we're going to be prompted for the values that that we were given in the problem. And so let's go down and enter a sigma of 10. We can enter our x bar of 105.2, and we can enter our sample size of 75. Now the nice thing is with C level, you can either put 0.95 or you can put 95 without the decimal point. It's going to lead you to the same answer. And so I'm going to go down and press calculate, and there you go. That's exactly what we got before. And basically the calculator has stored in it the exact same formula that I generated in video number 1. And so this nice tool that they've got for us allows us to not have to worry about the algebra so much, and we can just put in some of the important information to get the confidence interval. And remember, this would mean that we have 95% confidence that the true population mean is inside this interval. Okay, now sometimes you're actually going to be finding confidence intervals that are not 95% confidence intervals. Sometimes you're going to talk about a 90% confidence interval, or we talk about a 98% confidence interval, or a 99% confidence interval, and actually we can come up with whatever percentage we want. And the reality of it is the theory behind those is the exact same as the theory that we went through in video 1 with the 95% confidence interval. Everything kind of ultimately goes back to that empirical rule, and you would be looking at, for instance, with a 90% confidence interval, 90% of your data in a normal distribution would be within so many distributions of the mean, and that would impact one of the key values in that margin of error in that confidence interval formula. And so I'm going to show you what the formula is right now, but again, the formulas are going to be built into the calculator, so you're not going to have to worry about that. So here this says a 90% confidence interval has a margin of error of 1.645 standard deviations of the sample mean on both sides of the sample mean. So that basically supports the fact in the theory that that 90% of your data in a normal distribution is within 1.645 standard deviations of the mean. And so based upon that, that's how we ultimately come up with our formula for the confidence interval for, in this case, a 90% confidence interval. And so it would look like this. Our formula would be x bar plus or minus 1.645 times the standard deviation of the distribution of sample means. Or a 98% confidence interval has a margin of error of 2.326 standard deviations of the sample mean on both sides. And so that formula would look like this. It would be x bar plus or minus 2.326 times sigma over root of n. Or a 99% confidence interval would be x bar plus or minus 2.576 times sigma divided by root of m. You are not going to have to use these formulas, and I'm going to show you a couple questions that you might be asked related to these things, but all of this can be done by manipulating some of those things inside z-interval in the calculator. Now, I do want to say briefly that, a lot of times students wonder, well, why would you not have the largest level of confidence possible when you're trying to estimate a true population mean? So what's the downside to increasing the confidence level? And you should know that there in fact is a downside, and we could see that by just playing around with this. And so let's just pretend for a second that we go back into z-interval and we do change. I'm going to go to tests, and z-interval is number 7, and let's change that confidence level to 99. And remember, it could be 0.99 or 99, it doesn't matter. So we hit calculate, and so you can see that a 99% confidence interval for our IQ problem ends up getting a little bit wider. And so this is actually really good to observe, because we see that, while we might be increasing our confidence that the true population mean is in an interval, we're doing so at the cost of widening that interval a lot. And so let's just make the note right now that increasing your confidence level, increases your margin of error. In other words, it widens that interval. And in a lot of senses, when you have a very wide confidence interval, it's less informative. Like if I said to you, hey, I know the proportion of people who are going to vote for a candidate in the next election, and it's somewhere between 10 and 90%. That's an extremely wide confidence interval, but it doesn't have any information. And so there's a balancing act that we do in terms of giving ourselves a lot of confidence that our true population mean is going to be inside an interval, while at the same time considering how wide an interval is. So sometimes I actually will ask you that question. I'll say, what is not necessarily how wide is an interval, but what is the margin of error in a confidence interval? And if you do get that margin of error question, please know that you don't have to use these formulas, because this would be a margin of error for a 99% confidence interval. This would be a margin of error for a 98, and this would be what you would use in order to find the margin of error for a 90% confidence interval. But you don't need to worry about that, because a margin of error is simply the difference between one endpoint of your confidence interval and your point estimate. Or you could look at the total distance between one endpoint of your interval and the other endpoint of the interval, and then divide by 2. So please know that in the calculator you can find margins of error by saying one endpoint of that interval minus the point estimate, or you could say the point estimate minus the low end point of the interval. So I'll just add that right here. I'll say in the calculator, margin of error can be found, so we can avoid these formulas, and it is, I'll say the right endpoint minus the point estimate, or we can likewise say that it would be the point estimate minus the left endpoint. And so in our example, if we just go back to the original interval that we had, so let me change this back just to go back to the basic one where we had the 95% confidence interval. So I'm going to change my confidence level back to 95%. Our margin of error in this would be 107.46 minus 105.2. And so we can put this into the calculator, 107.46 minus 105.2, and we get an answer of 2.26. So please compute margins of error using your calculator. And and just about everything in this module and moving forward, we're going to be able to do in the calculator. I could even say things like, let's modify the sample size, and let's pretend in our example that the sample size was not 75 when we got a mean of 105.2 in the IQ problem. Let's pretend that we had a higher sample size. And so what is the impact on the confidence interval with an increased sample size? And so the impact of an increased sample size can be seen by going back into Z interval, and again, let's pretend that our sample size wasn't 75, let's pretend that it was 125. And if we calculated, look at what happens to that interval. That interval goes to 103.45 up to 106.95, approximately 107. And so increasing a sample size actually makes that interval narrower. And that's, in a lot of senses, helpful because you're being much more informative with, with your interval. Your interval is much more specific here. So we have a little bit less variation, we have a little bit more specificity. And so this makes our confidence interval narrow. So these are a couple of really big facts that you should be familiar with. This idea of increasing the margin of error, widening the interval, and to go hand in hand with that, decreasing the margin of error would actually be, if you're decreasing the margin of error, you're going to be shortening the interval. Likewise, increasing a sample size ends up making the confidence interval more narrow, and then decreasing a sample size is going to give you that more variability again. And you can also see that by, by thinking about the results in these formulas right here of modifying n and things like that. So these are a couple of the big themes to think about, but the biggest thing for you all to know is that you can consider all of these big themes and these questions by just manipulating Z interval at this point in your calculator.